Okay, there you go. The recording started already. See, now talking about language or mathematical language, it is believed to be mathematical language can easily be understood by context and by convention. Now later we will talk about we will talk about what's the difference between understanding mathematical language in terms of context and in terms of convention. Let's start with context. Understanding this language in context is what we are working on a particular topics being studied. While convention is where mathematics and scientists have decided that particular symbol will have particular meaning. Now let's take a look at this one. Understanding the mathematical language in terms of context, accordingly, it is where we are working on a particular topics being studied. Okay? So we understand certain terms or things in math according to their context as it is applied in a particular field. So that's context wise. For example, there are terms that is used in statistics like this, but not necessarily the same in another field in math. Because remember, mathematics is also there is a various specialization when it comes to math. In general, we call it mathematics, but there are a lot of things under this area. Now, understanding also mathematical language according to uh, convention is accordingly it is where mathematicians and scientists have decided and agreed that a particular symbol will have a particular meaning. Meaning to say it's generally or widely accepted. Like for instance, the pi across fields in math or across realms in mathematics, pi has the same meaning. The symbol pi has the same meaning. May you use it in trigonometry. You're going to use it in, for example, in physics. Like physics is also applied mathematics. Uh, where else? In calculus, the symbol pi have the same meaning. It is by convention understood that we are all going to use or understand. We're going to take pi as approximately 3.1614. Also, like for instance, the convention when it comes to solving problem using the PEMDAS rule. Okay, it's convention or it's understood that wherever you go, it's the convention of dealing such problem in math is that you go with order like PEMDAS, the parenthesis first, and then followed by um, exponent, then either multiplication or division, and then afterwards either addition or subtraction. That's the convention. That across field wherever you are, we share the same understanding when we are dealing with mathematical operations. Okay, so take note. Understanding mathematical language has there are two ways to take them. First is we will understand the language in terms of context. That's how we understand and look at mathematical terms according to the field that the subject is being studied. And then second is convention. It is where we take mathematical symbols and the mathematical language in general uh, as agreed by mathematicians and scientists. Now, also the mathematical language is the system used to communicate mathematical ideas. So when it comes to, that's why it's universal in nature. It's because when we discourse or when we have discourse, mathematical discourse, we are going to use the language, the mathematical language. Okay, we don't rely much on the English or Filipino, or shall I say like Spanish, whatever language that perhaps there is. We don't use them in the context of mathematics. We share when it comes to having a discourse in mathematics. We use the mathematical language. Do not be confused that you thought that what's used in mathematical discourse is English. No, we are using um, we're using math or mathematical language. That's why I have got a friend who told me, they've attended an international convention. They barely could understand the speaker presenting his paper in mathematics. I forgot the title of the paper. Because like he is I forget if he is a Taiwanese or Thai mathematical enthusiast, but they said the moment he started to discuss already the principle of his paper, which are introducing the mathematical concepts and all, that's the only time they understood him. But along the feelers and then the the way he started the conversation, they barely could understand the speaker. It's because of his accent. Okay, but as he discussed already, the papers, the content of the papers, which are actually all mathematical, symbols, numbers, and all, still, I mean, it made them understand. See, there is a barrier between the speaker and then the audience when it comes to the day-to-day conversation, like, for example, greeting them. But the moment he started talking about mathematical concept, since internationally, we share the same language when it comes to mathematical discourse, which is the mathematical language, still we will understand each other because we only share one language, and that is called mathematical language. So in any mathematical discourse or in communicating mathematical ideas, concepts, we communicate it through the language called mathematical language. Okay? Now, being said earlier that there are three characteristics of this language, which are precise, concise, and powerful. Precision means, in mathematics, means like it's a culture of being correct all the time. Now, you have to understand that one of the characteristics of the so-called mathematical language is always correct all the time. There might be a misinterpretation or at least an error somewhere along the way, but it's the implementation or how the language was used. But by nature itself, the language is correct all the time. In fact, that's what is its characteristic. So if there might be failure in the process, then it is the implementation or the using of the language, but not the language itself. Okay, take note of that. Second characteristic is uh, mathematical language must be concise or show simplicity. So by nature, the language is trying to make or break the stigma of confusion and difficulty, because what the language is trying to achieve is making things as simple and as easy as possible. Of course, easy here is actually is not absolute. It depends on your exposure to the language. You're more exposed, the more exposed you are to the language, then your context of easy is different from those who barely indulge themselves in the language. Okay, take note of that. And lastly, mathematical language is also powerful. Powerful in the sense that uh, it is a way of expressing complex thoughts with relative ease. It's like saying that it has a command that through the concept of mathematical language or today's language, the complexity of math in general is now being break down into more simpler and easier way. And aside from that, it is the only language that connects everybody across the globe without with the same interpretation. Like for example, if there are people whom you cannot understand or doesn't know how to speak English, for instance, still when you talk to them with numbers and mathematical using the mathematical language, I doubt they will still understand or you will still understand with each other. Just imagine talking to, like for example, a Korean who doesn't know or a zero English, but when you say two, three, or numbers, they will still understand you, right? I mean, based on my experience, I don't know with your experience or exposure too, but at least that's a good example that wherever you are, from whatever walks of life you have, when we talk about mathematical discourse using the mathematical language, still we have the same idea or we will still understand each other. So far, any question until this part before I'll move to the next part? Any question? Hello? Is there any question? Do you have a question or should I proceed?
None, sir, none.
Okay. So, talking about mathematics, there is also these things that we have to consider. Like English language and other languages, there is what we call sentence in math, and there is also what we call expression. Okay? So we're not trying to look, okay, we're trying to look at now the difference between the expression and then sentence or sentences in the so-called mathematical language. Now, if you're going to tell me, or at least can someone tell me, what is expression in math and what is sentences or sentence in mathematics? Anyone? Let's hear from Delfino. What must be expression and what must be sentence in mathematics?
Um,
Yes, Delfino.
I think the expressions there are the variable that used for sir,
Mhm.
or maybe the exponent.
Okay. Thank you for that. Any other thought? What is expression? You can raise your hand. You can use the raise your hand button. Who else? Tiongzon. What is expression?
Tiongson, sir? Tiongson?
Yes.
A mathematical expression uh, involves a mathematical expression could be arranged or not, while a mathematical sentence is arranged properly.
Okay. It's like this. The same in English. When we say expression, mathematical expression, it is something that does not express a complete meaning or thought, something like that. While sentence, it is the same time. On the other hand, rather, it expresses a complete meaning or thought. Okay, that's the difference between mathematical expression and mathematical sentence. If I'm right here, it's a finite combination of symbols that well defined according to rules that depends on context. Okay? Currently, mathematical expression is a finite combination. So finite meaning to say limited. There's an end. It's a combination of symbols that were well defined according to the rules that depends on the context. Remember when we take mathematical language, we can take them either convention or context wise. So in this case, we talk about expression. It's a combination of finite symbols wherein these symbols are uh, well defined according to the rules that depends on them. The symbols can be designated numbers. Okay, example of the symbols here are numbers, and even variables, operations, functions, brackets are also known as symbol groupings, punctuations, and like I said, now symbol groupings to help determine order of the mathematical symbol use, sorry, order of operations, and other aspects of mathematical syntax. It's okay. So expression is a correct arrangement of thought, and it cannot be determined if whether true or false. Sometimes some types of expressions are numbers, sets, and function. Now take note of this. Uh, when we talk about expression, like I told you, it is well defined, but you can barely tell whether it's true or false. You cannot completely right then say whatever it is, it's because it does not express a complete meaning. It's just something that it's there, precise, it's exact, it's correct, but you don't exactly know what is its equivalent, exact equivalent. Okay, and then like I said, the symbols can determine numbers, variables, operation functions, brackets, punctuations, and groupings to help determine order operations and other aspects of mathematical syntax. Can you give me a moment? Uh, I'll just be. Okay, sorry for cutting there. Now, speaking of, as we continue, that is the mathematical expression. On the other hand, when we talk about sentence or mathematical sentence, makes a statement about two or more expressions. So this time, when we talk about sentence, it is a combination of two or more expressions. Okay? Two or more expressions that were combined. Okay? So, an example of expression here, for we talk about the example of expression, let's say you have 2x squared. 2x squared is an expression. See, you cannot tell whether 2x squared is true or false. Can you tell me the 2x squared is true or it's false? We can't. Actually, we don't even exactly know what's x. For an x here is a variable used. But there is a correct order here. But the numbers and the symbols combined together, we know that we've got here two here. The first two is an coefficient, and then x here is a variable representing any number for whatever number is that, and we've got two here, another two, which is an exponent. And we know that the syntax of this, the ruling, that we know that the variable x was raised to the second power, meaning to say whatever its value will be multiplied, will appear as a factor twice. So this is an example of an expression. Another expression also, let's say you have, let's say 5y, for example. That's another example of expression. Still, we don't know what is its meaning. We can also say two as another example of expression. See? So this is an example expression, but when you say sentence or sentences or mathematical sentence, I told you last time that, or earlier, that it expresses a complete meaning or thought. Hence here, um, through the means of evaluation, we can tell already whether it's true or false. Remember, it's a combination of two or more expressions. For example, if we will combine these expressions here, then we can have already the so-called mathematical sentence. But of course, there must be a presence of a connector, okay? Something that will join or combine them. We call them as, I mean, there is a specific name for them, but they are what we call our, uh, the symbols or mathematical symbols that would join two or more expression. It could be greater than, okay, we can use equality symbol through, actually, through equality symbol or inequality. Okay, what is equality or inequality? Of course, when you say equality, we're referring to the equal symbol. And then inequality, that is the non-equal symbol, like the greater than or equal to, less than or equal to, not equal to, something like that. These are our symbol now that gives meaning to our, or that makes our statement here complete. Okay? Like for example, we'll combine this one. You have 2x squared plus 5y. Of course, we can use this another symbol. We use and then equals 2, for instance. So we have here the so-called equation. This is now considered as a sentence or mathematical sentence, where it expresses a complete thought or meaning. It says here that the expression 2 to the x combined with another expression 5y is equal to 2. Now, by judgment later on, we can already do a mathematical manipulation to test whether this is true or false. But unlike here, we could barely, there's no way for us to tell whether this is true or false. Okay? Unless we will equate x to any value and then find whatever is the value of the expression. And that makes now a sentence. Okay, for example, we don't know what's 2x, so it's 2x squared. Now, to give meaning to this one, if we will say equals 2, now from there, we can already find the value. Let's say 4. So this is already a sentence, but taking it separately like that, that's an expression, or that is an expression 4. But with this symbol, the old symbol here, that makes this expression, the two expressions combined together, and thus we call them sentence or mathematical sentence. So from now, we can tell already whether this is true or false. By virtue of evaluation and manipulation, we can tell now whether this is true or false. Let's find out. So this is going to be, okay, divided by 2, divided by 2, you have x squared equals 2, extracting. Thus, you have x equals the square root of 2. Okay? Now, in this expression here, there is a certain condition that will make the sentence here true. The mathematical sentence 2 to 2x squared equals 4 to be true, provided our x is equal to the square root of 2. Okay, so there are already restriction. So in this condition, there is certain ruling that make the statement true. But taking it separately, this one as an expression and another one as an expression, there's nothing more that you can tell about, as they are just barely, or they're just simply expressions. Okay? Do you now know the difference, or I hope the difference between expression and sentence are now clear to you. I just need someone to make a very quick recap as to the difference between expression and sentence. Let's hear from Villarreal. If you may try to recapitulate the difference between expression and sentence. Go ahead.
Um, to answer, expressions are finite, more on symbols, and then sentence are like kanang mathematical statements. or no? No?
Yes.
I To answer, expressions are finite combinations of symbols, and then while sentence are combinations of two or more expressions that were combined.
Okay. So if you can you guys give me an example of an expression, mathematical expression, and then also an example of mathematical sentence? Go ahead. Just an example.
Ay, kanang for expressions are like just same sa imong example like 5x squared, and for sentence ay gi-combine ang tawagan na variables by putting an um, like symbol like plus or minus sign to it.
Okay. So by the way, class, even when you say x equals 5, this is already a sentence. Because first and foremost, x here is an expression. And while 5 is another expression. As they were combined using our equality symbol here, they were combined as x equals 5. Then this expresses a complete thought. It This expression says, or this statement says that an x is equal to 5. So it expresses a complete meaning or idea, expresses a complete thought. That makes this statement here as I mean, this that makes this given here as an example of expression sentence or uh, yeah, sentence, mathematical sentence. But if you're going to look at it like x here, x 5, and then you have 5, for example. You also have e. You also have uh, the phi, the phi we have for the golden ratio. These are all expression. But whenever you combine them like this, or let's say you have pi is equal to approximately 3.14. So that's an example of a statement. It expresses a complete thought this time that you have a symbol, an expression pi, which its value is approximately 3.14. So it expresses now a complete meaning, or it expresses a complete thought. Well, when you have it like this, x5, you just know that that's x, it as a variable, or 5 as a number, but it doesn't express as a complete thought. It doesn't express as a complete meaning to us. Unlike when you put it like this, combining it with a symbol such as equality or the approximate symbol, the inequality symbol, and among other symbols that would combine two or more expression, which now make or expresses the two expression being combined together, you have already a complete meaning, or at least a complete thought for your given. Okay, thank you for that. And is there any question about expression in sentence? Anyone?
Kanang question lang sir kanang
Yes, Alibaga.
kanang equation sir og ang sentence the same lang na sila sir or iba ang equation.
Equation is an example of mathematical sentence. We call it mathematical equation because a mathematical equation is actually a combination of two or more expressions which were now combined using equality or the equal symbol. That makes uh, an equation, mathematical equation, as an example of mathematical sentence. In other words, mathematical equation is just one of the examples you can have when it comes to mathematical sentence. Okay? I hope I answered that, Sulibaga.
Yes sir. Thank you sir.
Any other clarification? Okay, I think we're good. Now, I'd like to introduce to you. There are what we call basic four basic concepts in mathematics. Now, as understood, when you hear the word basic, these are the fundamental concepts in math. I don't know if you will agree with me, but fundamental, fundamental or the basic or the foundation when we talk about mathematical discourse. So, what are these four? The four fundamental concepts in math are the so-called uh, set, and then we have functions and relations, followed by the binary operations. And then the last is, where is that be here? I think the last is logic. The language serves as a tool for teaching mathematical concepts. Okay, the mathematical language accordingly is a tool for teaching mathematical concepts. So it's like this. I cannot, or the only way for me to relate to you or to introduce to you the mathematical concepts is by means of using the mathematical language. If there is no such thing as mathematical language available, I do not know how am I gonna communicate to you the concepts in math. Okay, I hope that's clear. Now, there are what we call basic concepts in mathematics, meaning to say one must have an understanding of these basic concepts because this will only ripple. Once you understood these concepts, later on the rest will just follow. It can show how to make syntax and structures of mathematical language clear and explicit to understand the fundamental mathematical concepts. Language serves as a major pedagogical tool to understand how, what, and why things are said. We need to be familiarized with the four basic concepts in mathematics before moving to more complicated mathematical structures. So it says here, as these concepts are fundamental or basic, we need, according to the author, we need to understand or at least know the four basic before we move further because the rest will just follow. Okay? As these concepts are fundamental, they are somehow the rest of other complicated mathematical concepts are nothing but dependent on these principles or these concepts. Let's start with the first language that talks about the one of the basic concepts of math, the language of sets. Okay, we have the language of sets. We need to understand first what is set. Anyone? What is set?
Just a group of expressions, sir, or group of numbers.
I'll just try to pin my, but I won't keep on moving. Ah, wait. I think I have to do that here. Huh, 29. Where are the rest? Okay. Is it blurry in your end?
Yes, sir.
Sometimes,
I think that is when movements see like that it's clear, but when
Pag nag-move ka, sir, mag-blur siya.
now when it loses its focus, Because if it's like that, it's clear. But when I move it like this,
Yes,
it
sir.
will be blurry. Anyway, so set set is actually known as collection of a defined objects. Okay, where the objects here is called elements or member, member or members, object or objects. Okay, so you look at that one. We have here the language of set. By the way, in math, there is what we call set theory. Set theory is a branch of mathematics uh, like algebra, trigonometry, geometry, calculus, and among other branches of mathematics. We have one branch of math which is called the set theory. Okay, it's called set theory. Now, set theory class is also known as the mathematics of, or it's a mathematical science of finite or infinite. Mathematical science of infinite. Of course, we know what an infinite is. It doesn't have, or an infinite refers to something. It would translate it in a very more easier term is called the forever. So it's like set theory is the mathematical uh, or the mathematical science that deals with forever. Okay, so its concern is infinite. So set theory is actually subject. To make it more simple, it's a subject. Okay, it's a branch of mathematics that deals with the infinite, that deals with the forever. Okay, so when we talk about sets in general, its basic definition refers to the collection of well-defined objects. So the collection of our well-defined objects. And these objects are called elements or members of the so-called set. Okay? These objects are called elements or members. Now, let's look at this. Okay, so much for the introduction. We denote here, by the way, uh, the element. We use the symbol like this to signify element. And then we use the symbol like this if it implies not an element of the set. Now, for example, if I have here, uh, let's say, for example, the collection of letters of the word loud, okay? Because it says here the collection of well-defined objects. Now, in this case, I have here the collections of the letters in the word loud. Okay, Love. So it's a well-defined objects. Now, in this case, my objects or the members of my set are the letters found in the word loud. Okay, so it's a collection of well-defined objects. By the way, since the set theory is the mathematical infinite, it doesn't also limit to the idea that only infinite. It also includes the finite. Because this example here is an example of a finite set. Because there are two types of sets. We have the infinite set and then the finite set. This is an example of a finite set. Now, let me introduce you. By the way, we can put here capital letter. Example. This is, by the way, the capital letter here that we associate to this collection of objects is called the name of the set. Okay, name of the set. So we call now this is set A, which is defined to be the collection of letters in the word love. So this capital, take note capital letter. We use capital letter in naming a set. So the collection, we have here a set called A, which is defined to be the letters and the word love. By the way, this symbol here, the symbol of group is used, this two. This is called yes, set builder notation. Set builder notation. It means to say, whenever you find like this, or whenever there are elements inside this one, it implies one thing. Convention-wise, it's understood that it is set. Again, I already used the term convention and context. Now, or I should say, I'm not sure if it's context or convention, but I think it's convention. That whenever you found elements or objects or expressions, okay, this is called expression. This is another expression. But this whole thing here is an example of a sentence, mathematical sentence that includes A here equals this expression. So looking at it, this is an expression. While this is an expression, as they were combined now with the equality symbol, then that makes a sentence. Okay, we look at this one. When I have this term here, collection of
Sir, excuse me, sir.
expressions. Yes.
Ah, ang board sir ba murag wala na na-cover ang imong gipangsuat wala na na-cover sa camera. Murag bawas na. You pull the board
Yes, sir. Half
uh,
na, sir,
to
ang
the right.
board, sir.
You might be referring because it's clear. I mean, that was the other screen because I'm actually using two screens.
Sa kuan sir sa board nga screen.
Yeah, actually,
Murag
I'm
wala
watching
ang
it from my end. It was full.
Half
Are
na,
you
sir.
seeing me full? Are
yes
you
sir.
seeing me?
Yes
No,
sir.
no.
Ang
You
board
you
kay
have to look at the other screen.
Yes, sir. Sa lain na screen,
half
sir,
na
sa
Japan
board.
sir.
Inyo ipin para makita tanan.
You pin the other gadget I am using.
Well, it rotates siya, sir, para makita tanan.
Okay na, sir.
You pin the other gadget because I also pinned it from my end so that you're not seeing me talking, but you can see the board. Are we good?
Good na sir, good na sir, good.
Yes, sir.
Okay, so because I tried to open I can close my one camera, but I'm trying to make it a point that you can see also me while talking. At least it's not awkward that you're only hearing my voice but not seeing me. So at the same time, you are seeing the board and you are also seeing me. Is that possible?
Yes sir.
Yes, sir.
Okay. So can I continue now?
Yes, sir.
Yes sir.
Okay. So like where am I? I was telling earlier that this is called the set builder notation. Now in this situation or situations here, I said that it's a collection of well-defined objects, and the objects here are called elements. So LOVE here are also called the elements of our set A here. Okay? So the elements of set A here are LOVE. Okay? So that's an example. And then with that saying, so we can actually come up here with, so we have E, or for example, E is an element of A. Do you notice that? So the object here, E, is identified to be a member or element of the so-called set A. On the other hand, U is not, okay, not an element of A. Because in this particular set that we have, there is no U. So in other words, the object U perhaps belongs to another set, but not to set A. Okay? I hope that's clear. Question?
None so far, sir.
Okay. So, also, like for example, I have a collection of well-defined objects. So, for example, set A defined to be the collection of land transportation such as bus, tricycle, and motorcycle. So I've got three elements there. So can you please name me at least one element of the set? How would you express its notation? So we can
Bus is
say
an
that,
element of
okay, we have bus is an element of B, where B here is a set uh, containing mode of transportation, land transportation. And then on the other hand, jet is not an element of B because jet, on the other hand, uh, is not a member of B. I can give you another example. Please do not hesitate to ask questions if you have some questions. Okay, another example. We have example E or A rather. You have A is okay. So I have here an example. Set A, the name of my set is A, which is defined to be X, such that X is a positive integer less than 10. So I've got here my set builder notation, and then I have here this description of my elements. By the way, in this kind of set here, we did not we did not list down the members of the set, but we describe the members of the set. The members of A are X, described to be a positive integer less than 10. So this type of presenting set is in description method. By the way, there are two types of writing set. Okay, we have first one is we have the rooster method, and then the second one is we have the rule method. What's the difference between the two? The rooster method is simply the first example I gave you where we listed down the elements of the set. Okay, the example I gave you that A is a set containing the letters LOVE, the word love. That's an example of rooster method. Again, rooster method is writing set wherein we enumerated or we list down the members or the elements of the set. While rule method is actually a manner of presenting set wherein we just state or describe the rule that governs or the rule of or the description of the set. Okay, so this is an example of rule method. Okay, so if you notice, I have here this symbol. We read this one as X, such that this is read as such that X. So in other words, we have here, remember we use variable to denote a certain thing or we assign something to X. So X here is a variable. And then such that that variable is described to be a positive integer. Now, if I'm going to write this one, this is an example of rule method. But in rooster method, this is equivalent to a set builder notation is a positive integer less than 10. Take note, positive integer. Now, the rule for this set refers to a number or an integer that is greater than uh, greater than -1, but less than 10. So I can write here 0, 1,
1,
2.
2, 3, 4, up to 9.
Okay. By the way, 0 is wait. I think 0 is not included. I'm not sure. Is 0 part of the positive integer? My mind is not working. Because 0 is not, it's neutral, neither positive nor negative. But in the positive set of positive integer, I think 0 is not included. Please forgive me, I think it's not included. So it includes only 1 to 9. So this is the example of the rooster method. Well, the rule method is this one. Okay. So these are our x's now. This is x sub 1, x sub 2, until x sub 9, for example. Okay? The x sub 9 is equal to 9, for that is the last entry. And the numbers included here are only integers, positive integers. We drop the negative because the negative numbers are still integers, less than 10. But there is in the description, it says positive integers only. So thus we have to drop the negative integers. Okay, so we have here an example of a set called set A, which is positive integers. So we have the rule method, the rooster method, also known as the tabulation method, rooster or tabulation, tabulation method. Tabulation because we simply tabulate, we simply list down everything. Okay, we have the rule method and then the tabulation or rooster method. Any question? Please, you ask question.
None so far, sir.
Okay, next. I'll give you here an example and then you try to write this into a set builder notation form. Okay? I have here E is a set containing A, B, I, O, B. Okay, this is an example of what method of writing set. Anyone? Just raise your hand.
What's the question, sir?
This is an example of what method and in
Raster
naming a set.
method, sir.
Okay, we
Raster
have the
method.
rooster method. Who can give me the equivalent rule method for this? What's the equivalent rule method for this given set? Set E.
X such as X that are vowel letters.
Again.
Vowel letters, sir.
No, the whole statement.
X such as X are letters that are considered as vowels.
Okay, it's like this. We may improve that one by saying this one. We have set E, or set E is a set containing, okay, set A is a set containing X such that X is a vowel letter. Vowel letter of the English alphabet. Alphabet. Is my spelling correct? Is my spelling correct? Please correct me if my spelling is wrong. Okay. We may write it in rule method as set A containing X such that X is a vowel letter of the English alphabet. We have to be specific. We have to be precise with our description because, of course, there are other sets of letters or vowel letters. Of course, you have the you have the Filipino vowel letters, or at least we have the Greek letters also, so and many more. So we may write this set as set A containing X such that X is a vowel letters of the English alphabet. Any question with this example? Before I'll mention the next term. I'll just try to introduce the terms and later I'll introduce to you the symbol and the operation, by the way, of sets. Because the same and the other, there is also operations involved for sets. Now, the next term I would like to introduce is we have the finite. I already mentioned earlier that finite set is a set whose elements are limited or countable. Limited or countable. So the elements in finite set is limited or countable. Now, if you look at set E here, do you think it's a finite set?
Yes, sir.
Why?
It's limited.
Okay, you notice our elements are only letters. They're only countable. A, E, I, O, U. We have only 5 elements or members of set E. Thus, this is an example of a finite set. On the other hand, we have the infinite set. So, infinite set is the opposite. Unlimited or at the same time, non-countable. Or in words, the last element, at least the last element is not defined or identified. Identified. That is for infinite set. So an infinite set is a set whose elements are not countable or cannot be counted. In other words, the last element of that set is not identified. Okay. Now, if I was going to ask you, the set, or I have a set here, I have set A containing letters of the English alphabet. Finite or infinite? Who's that? You can raise your hand.
Finite, sir.
Okay, we have why finite?
Kay koan siya, sir, kanang limited siya.
Okay, because that is only a limited set, or the members of the sets are limited. So the set containing letters of the English alphabet is known to be a finite set because that set elements are countable or the elements can be counted, thus it's considered a finite set. What about I have the set of positive integers? Finite or infinite?
Infinite, sir.
Why?
Unlimited man sa sir, daghan man kayo positive integers.
Yes, if that's the case, what is the last element of, or what is the last element for a set of positive integer? Huh? What is the
10, sir.
sorry? What is the last element in the set of positive integers?
Why siya 10, sir?
Wait, I'm asking you. It seems that you're asking me back.
10, sir.
Yet you're not consistent with your answer because earlier you said that it's infinite. Now you are trying to identify the last element of the set. Isn't it that I mentioned that when it is an infinite set, the last element is unidentified or was not
I
identified?
identified, sir.
So in other words, if we have the set of positive integers, we know now that the last element is unknown. At least guaranteed the last element is unknown. In fact, there are a lot of elements in that set that are not yet known. Until the only numbers that we can identify in our number system, that's the only thing that we have. But we will never know what's the last element for that set. We just know that it's a positive integer. Okay, that makes the set infinite. So we have the infinite set. By the way, there is also what we call a unit set. What is a unit set? What is a unit set? Hello? Hello? Can you hear
Yes, sir.
me?
Yes, sir.
Yes, sir.
Okay. So we have here the unit set. Unit set are also known as the single tone. Single tone is the so-called set containing
One element.
single. Okay, a set containing single element is called a unit set or single tone. So an example set A containing 1. This is an example of a unit set. Because the element of set A here is 1, that means to say it's a single tone or a unit set. On the other hand, we also have the empty set. Empty set, an example of which is example A containing, okay, whenever this is your symbol, no element inside, then it's called an empty or null set. Okay. It is in set theory, it's still conventional to say that there is what we call a set with no element at all. And that is called an empty set or a null set. Next, by the way, this is what we have for empty set, or we may write it as like this. There's a bar. That's an empty set. And then, so when you encounter like this is an example. Whenever you encounter you build a set builder notation without an element, then that is a null set or empty set. Or if you encounter a symbol like this, it implies an empty set. Another one is we have the capital U, which is called the universal set. It's always understood that any given set is a member of a much bigger set, which is a universal set. Okay, I'll just read to you the definition. In addition, all sets under investigation and any implication of set theory are assumed to be contained in some larger fixed set called universal set. For example, if I'll say this one, set A containing 1, we know that this set is a member, or the one here is a member of a larger set. Example, a set 1, 2, 3, 4. That is another set which is considered as a universal set. In other words, when you talk about universal set, it is a set containing all elements that is under investigation or consideration. Just always bear in mind that the universal set is a much bigger set wherein all the elements under investigation or considerations are member of which. It's called universal set, denoted by capital letter U. What else? We have now the cardinality of set. What is cardinality of set? Or cardinal number? Cardinal number, or the cardinality of set. It is the number of set in an in a given element. Example, I have here set A containing L, O, V, E. That's my E. So when you say the cardinality of A, that's denoted by the symbol N of A. That is 4. Cardinality of set refers to the number or the amount of elements in a given set. In this case, we have 4 elements, L, O, V, E. Thus, the cardinality of A is 4. Okay, or the cardinal number of set A is 4. It means to say that there are 4 elements contained in set A. And those elements are 1, L, O, V, E. Okay, that's cardinality of set. Can someone give me an example of a set B whose cardinality is 2? Just give me an example. Anyone who can give me an example? Peralta.
I'm still figuring out, sir, sa example, sir.
You just give me an example of a set whose elements there are 2 members. Any.
I 1 and 2, sir.
Okay. So, for example, you have the set B containing 1 and 2. This is a set, the cardinality of this set is 2 because there are 2 elements involved in the given set. Okay? That is cardinality of set. Then you say here, subset. In symbol or in principle, we have here I'll have here B set containing O and E, for example. So when you say subset, in principle, that is B is a subset of A. It means to say the elements of set B are elements in A. So for example, if you notice the elements of B, O, and E are in E and A, it implies that B is a subset of A. In other words, B is smaller than A, wherein the elements contained in B are also contained in A. Do you get me? In fact, this is called, this example is a proper subset. Proper subset meaning to say all the members of these sets are member of the other set, but there is at least one member of A that is not in B. So in this case, we have L and E who are not members of B. Thus, we call this situation B here is the proper subset of A. But the generic, when you say B is a subset, because there is also an equal sets. I don't have here the symbol, but there is what we call equivalent set and equal set. When you say equal set, B equals A, elements of B and elements of B are the same. They have exactly the same element. But when you say B equivalent to A, they have the same, the implication of this one, N of B is equal to N of A. The elements, the cardinality of B is equal to the cardinality of A. That means to say they are equivalent set. But the elements of A and the elements of B are exactly the same, and they are equivalent sets. So there is a difference between equivalent set and equal sets. There are equivalent sets that is also equal set, and there are also, all equal sets are equivalent set, but not all equivalent sets are equal sets. Did you get that? Okay, I'll just close this one, the session, by this symbol. Okay, I'll just end with cardinality. I'll just wrap up next other time about the subset and its symbolic form. So expect that our activity this Thursday, Wednesday rather, is characteristic of mathematical language going to cardinal numbers or the cardinality of set. And then from there, next week, Monday, I'm going to discuss subsets and then the rest of the terms involved in set. Is there any question before I'll dismiss the class? You can open now your camera. We're good. Don't have question or clarification? I'll
Recorded
just
video,
post
sir ba?
this video, the recorded video for this one.
Moodle, sir, Moodle.
Yeah, actually, it's in my YouTube account. I would appreciate also if you will subscribe.
Yes, sir.
Paano sa
Okay.
pag-prelim, sir?
I'm still waiting for the schedule. I heard it's first week of March, but I'm not sure when is the exact schedule.
Okay, sir. Thank you.
Are you sure you don't have question? I'll just end this one first. Okay. You can open now your camera and say bye to your classmates. Just be ready for the activity by Wednesday. By the way, wait. Wednesday is holiday, right?
Yes, sir.
Okay, I'll post the activity, but I'll just leave it open. You can take it anytime during the day, but I will not impose it on our schedule. I'll just have
Nasa siya ma-close, sir?
to... Huh?
Nasa siya ma-close?
Available na siya.
Available siya the whole day. So it's up to you when you're going to take it. I have to give that to Wednesday, otherwise, because if I'm going to give that one Monday next week, we'll just gonna be very behind already with our lesson. Okay? You can take it anytime within the day by Wednesday for the activity. I'll not impose it during our period.
Okay, sir.
Okay. So with that saying, you can go now and see you next Monday on our live conference.
Bye, sir.
Bye.
Bye, sir.
Yes, sir.
Bye, sir.
Sir.
Bye, sir.